Good day again, students, and welcome back to my pre-calculus class. Last time we were looking at um, other trigonometric functions. That is, we consider tangents of angles, cotangent of angles, secant of angles, and cosecant of angles, in addition to sine and cosine of angles. And we looked into some examples. Today, briefly, we are going to be looking at another way to finding um, these six trigonometric functions. Before that, let us revise some ideas from um, our pre-calculus 1 class. So, consider the functions f of x equals to x squared and g of x equals to x raised to power 3. So let us start with this function. F of x equals to x squared. Now, I'm going to do this. F of x equals to x squared. So I will pick some points, -2, -1, 0, 1, 2. If I find the y value, that is f of each of these inputs, here will be 4, here will be 1, here will be 0, here will be 1, here will be 4. And we do notice that f of -2 is exactly the same as f of 2. That is, we can see this is 4, this is 4. Also, f of -1 is the same thing as f of 1, right? F of -1 is 1, and f of 1 is also 1. In general, we can say f of negative inputs equals to f of positive input. When our function behaves this way, we say it is an even function. It is an even function. That is, the function evaluated at the negative input is giving the same output as when the function is evaluated at positive input. So we say that function is an even function. Also, let us look at this. F of x, in this case, I say g, let me say g of x equals to x raised to power 3. Again, I pick some points, say x, this is g of x equals to x raised to power 3. And I have, again, -2, -1, 0, 1, 2. G of -2, if I evaluate it using this function, this will be -8, this will be -1, this will be 0, this will be 1, this will be 8. That is -2 raised to power 3, for example. That is -2 times -2 times -2, which is -8. Okay. Now, again, we observe that G of -2 is, quick question, G of -2, is it the same as G of 2? That is, G of -2 is -8, but G of 2 is 8, not -8. It turns out that if I want them to be equal, I need to multiply this by -1, so to say. So that means G of -2 is the same thing as -G of 2. The same thing, look at G of -1. G of -1, which is -1. But if we look at G of 1, which is 1, G of 1 is 1. It's not the same as this. If I want that to be the same, I need to multiply this by negative. So again, it means I can do this. In general, I can say G of negative inputs equals to negative of g of positive input. So for any function that behaves this way, we say it is an odd function. It is an odd function. So if your teacher asks you to give example of an even function, just say x raised to power 2, the quadratic function. And that of x raised to power 3 is an example of an odd function. Okay, how does that help us to solve problems involving trigonometry? Let us look at something, cosine. So, okay, cosine of, let's say, pi over 6 and cosine of negative pi over 6. Let us see how they are related. Cosine of pi over 6, let us quickly return to unit circle. You should know this by now. Pi over 6 is here. So, like I taught you, because this is the longer side for x here, so that is root 3 over 2, comma 1 over 2. Now, cosine here is root 3 over 2. What about negative pi over 6 here? That is, right, the negative angle for that. We go clockwise, and the reference angle is still root 3 over, the reference angle is still pi over 6, and the terminal points will be this. We have learned this in the past. Now, in this quadrant, x is positive. So, which means this part is positive and y is negative here. So, it turns out that cosine of negative pi over 6 is still root 3 over 2. Now, what do we see? That implies that cosine of negative pi over 6 is the same thing as cosine of pi over 6. Can we see behaving like this? So we say cosine function in general is an even function. It's an even function. And similarly, let us look at sine of negative pi over 6. Negative pi over 6, we've already done that, so we just pick the answer. The sine, which is the y value, is negative 1/2. Then sine of pi over 6, which is here, sine of pi over 6, which is the y value here, is 1/2. We do notice that that implies that sine of negative pi over 6, whatever the value is the opposite. Okay, this is minus and this is plus here, right? So sine of pi over 6. And we say this implies that sine function is an odd function. It's an odd function. So, in general, so I've stated this. So in general, we claim that cosine and secant are even function. So these two guys are even. And these other four are odd functions, odd trigonometric functions. And we can see how they are defined now. Secant of negative angle, because it is even, will become secant of positive angle. Here tangent is odd function, so that means tangent of negative angle is going to be negative of tangent of positive angle. So, and so on for cosecant and cotangent. Nothing to memorize there. Just know that sine is odd, cosine is even. And remember, secant is the reciprocal of cosine. So that makes secant to be even function. Sine is odd. So the reciprocal of sine, which is cosecant, will be odd as well. Tangent is, let me quickly show you that of tangents. Tangents of an angle is sine of an angle over cosine of an angle. So if I do this, so that means this will be negative, this will be negative, right? Now, look at this. Since sine is odd, then I will have minus sine of t. Cosine is even, so I will have cosine of angle t. Now, what do we notice there? This equal to this negative, I carry it. Sine t divided by cosine t is tangent of t. So that is what makes tangent to be an odd function. So let us apply this new knowledge. If sine of angle t is 3 over 7, evaluate sine of negative t. Well, we do know that sine function is an odd function, meaning that sine of negative t is going to be negative sine of t. We know that. And we know that sine of t is given to be 3 over 7. So our answer is minus 3 over 7. Done. Okay. Let us look at this. Using the idea of odd and even function, find sine of t, cosine of t, tangent of t, secant of t, cosecant of t, and cotangent of t. So quickly, let us solve this. Our angle. So I will say solution. Our angle is negative pi over 3. Maybe we need this coming. So the first one, Roman figure 1, sine of t. Our t is negative pi over 3. So that is sine of negative pi over 3. Remember, sine is an odd function. So it becomes negative sine of pi over 3. So the question is, what is, so I have minus. So what is sine of pi over 3? Remember, pi over 3 is somewhere here. And that is 1/2 root 3 over 2. You should know that offhand. Okay. Now, the y value there is root 3 over 2. So, root 3 over 2. Answer. Roman figure 2. Cosine of t is the same thing as cosine of our t is negative pi over 3. However, remember that cosine is an even function, which means this whole thing is the same thing as cosine of pi over 3 from definition of even function. Now, what is the value for cosine of pi over 3? This is where we have pi over 3. The cosine here is 1/2. So, 1/2. Answer. The next one, let's say tangents of c, which is tangent of negative pi over 3. And it is, since tangent is an odd function, so that is negative 10 uh, pi over 3, which is negative tangent is sine of pi over 3 divided by cosine of pi over 3. So which is minus sine of pi over 3. We just learned here pi over 3 sine is root 3 over 2, root 3 over 2 divided by cosine of pi over 3 is 1/2. So that is minus root 3 over 2 times 2 over 1. And our answer is minus root 3. Answer. Okay, moving on. Let us go to the next one. Call it Roman figure 4. Let us look at secant of t. Secant of t is secant of our angle is negative pi over 3. Since secant is an even function, so that means it is equal to secant of pi over 3. And remember that secant is the reciprocal of cosine. So pi over 3. So which is 1 divided by, what is cosine of pi over 3? Again, we go here. Cosine of pi over 3 is 1/2. So that is 1/2. 1 divided by 1/2, that means your answer is 2. The next one, let us look for cosecant of t. Again, our cosecant, our angle rather, is negative pi over 3, which is, cosecant is an odd function. So it is negative cosecant of pi over 3. Remember that cosecant itself is the reciprocal of sine of that angle. So that is minus 1 over sine of pi over 3. So which is minus 1 divided by sine of pi over 3, sine of pi over 3, that is the y value, root 3 over 2. So that is root 3 over 2, which is negative 1 times 2 over root 3, which is negative 2 over root 3. Now we need to rationalize the denominator because we cannot leave our answer in that form. We do not want the radical to be at the denominator. So this is negative 2 root 3 over 3. Answer. And lastly, the last one, cotangent. Cotangent of angle T, which is cotangent of negative pi over 3. Since cotangent is an odd function, it means we have negative cotangent of pi over 3 from formula or from the definition of odd function. Again, we do know that cotangent is the reciprocal of tangent. So that means 1 over tangent of pi over 3, which is, have we found tangent of pi over 3? Okay. What we can do is, let's see, if we have, we do not make mistake here. Do not use the answer here because this is actually tangent of negative pi over 3, right? Not tangent of pi over 3. It is tangent of negative pi over 3. So um, which is negative root 3. But you should be able to move um, between the two, or let's take it step by step and see. So you can see that this is 1 divided by, let us do it this way. It will be easier. 1 divided by tangents of pi over 3 is 1 divided by tangent of pi over 3 is sine of pi over 3 over cosine of pi over 3. We are just trying to move to what we know. So which is 1 times cosine of pi over 3 divided by sine of pi over 3. So with that, we can say this is 1 times. So 1 times that, so that is cosine of pi over 3 divided by sine of pi over 3. And we learned earlier that cosine of pi over 3 here is 1/2, and so divided by sine of pi over 3 is sine of pi over 3 is root 3 over 2 here. I'm using this x, y. So the sine of pi over 3 is that. Finally, we have, this is 1/2 times 2 over root 3. So which is 1 over root 3. We need to rationalize that. So times root 3 over root 3. And finally, we have that our answer is root 3 over 3. Answer. Now, some of you would have noticed that, wait, can I use this cotangents of an angle? Is it the same thing as cosine of that angle divided by sine of that angle? Can I just use this one straight up? Yes, you can. So meaning you can just move from here straight up to this place without going through all this. So this is another way to represent cotangents. How did I get this? Remember, cotangent of t is reciprocal of tangents of t, and which is 1 divided by sine of t divided by cosine of t. And if we do your math well there, it should be cosine of t divided by sine of t. So this is another way to represent cotangent of t. Okay, so that is that with that example. I hope that is clear to us. All right. So we have used the idea of odd and even functions to find the 6 trig identities, the 6 trig functions, right? Okay, so I'm leaving this for you to solve using the idea of odd and even function. Find all this when your angle is -5 pi over 6. There is nothing new here, right? All what you need to do is to first find the terminal points for this. For example, sine of t is sine of -5 pi over 6. Since sine is an odd function, it becomes negative sine of 5 pi over 6. Now the question is, what is the terminal point for 5 pi over 6? Well, we can go back here to our unit circle, and 5 pi over 6, in my last video, I explained several ways to think about that. 5 pi over 6, one way to think about it is pi over 6 is 30. That is 180 divided by 6. That is 30. So pi over 6 itself is 30. 30 times 5 is 150. So it means it's going to be somewhere here. So if it is 150, it means that the reference angle will be 30 degrees, right? So remember, for 30 degrees, we have root 3 over 2, 1 over 2. So you just bring it here, root 3 over 2, 1 over 2. Now, since in the second quadrant, y is positive and x is negative. So you can just use that. So in this case, we have this minus written. So sine of 5 pi over 6. Sine is positive there. So I'm done. I'm done. So go ahead and find cosine of t, which is a cosine of negative 5 pi over 6. That is your angle. Since cosine is an even function, so it stays as cosine of 5 pi over 6. And with that, this is our 5 pi over 6 here. So the x value there is the x value there is negative root 3 over 2. Negative root 3 over 2. So that is that. That is that. Okay. Moving on, so I will leave you with the remaining parts: tangent, secant, cosecant, and cotangent. You should sort that out by yourself. The next thing we want to look into is using identities to simplify trigonometric expressions. So we do know that tangent of an angle is sine of that angle divided by cosine. Secant is the reciprocal of cosine. Cosecant is reciprocal of sine, and cotangent is the reciprocal of tangent, or cosine divided by sine of that angle, just like I explained a few minutes ago. Now, let us use that idea to simplify this trig expression. Well, secant of angle t divided by tangent of angle t is, remember, secant is the reciprocal of cosine of t, right? Divided by tangent of t. Tangent of t is, let me take this first step so that you don't get confused. I want to write this as secant of t divided by tangent of t. Okay. So which is 1 divided by cosine of t. That is the way to write for secant. For tangent, it is sine of t divided by cosine of t. So equals to 1 over cosine of t times cosine of t divided by sine of t. And this here 1, this here 1. So finally, we have 1 over sine of t. However, I do know that 1 over sine of t is cosecant of t. So we've been able to simplify that trig expression. What about this? Simplify tangents of angle t multiplied by cosine of angle t. So which is, tangent is sine of angle t divided by cosine of angle t times cosine of angle t. So this A1, this A1. So I have, my answer is sine of angle T. Answer. Okay, we will still revisit something like this in our um, classes to come, but for now, let us just leave it there. Okay, let us look at alternate forms of Pythagorean identity. Let me remind you, when we started this class, we talked about Pythagorean identity, where we say, okay, maybe we should go, I should take you real back. So we have this, we say this is angle T, and we have this, okay, and then we call this X, we call this Y, and this is our radius, which is 1 in this case for unit circle, a unit circle. And we say x squared plus y squared is 1. And we say, well, this is x comma y, which is the same thing as cosine of that angle, and this is sine of that angle. And then we say, well, that means cosine squared of that angle plus sine squared of that angle is 1. And we said this is a Pythagorean identity. We know this. Now, with that, let us look into something much more beautiful. What do I mean? From the Pythagorean, from Pythagorean identity, from the Pythagorean identity, that is cosine squared of angle t plus sine squared of angle t equals to 1. Can I do this? I can divide through by cosine squared of t. I'm dividing everything through by cosine squared of angle t. Okay, what do I get? Well, cosine squared of t divided by cosine squared of t, this is 1 plus sine of t divided by cosine of t is tangent of t. Then if I square this, it means I can square here. So meaning this becomes tangent squared of t. Now, 1 over cosine squared of t is the same thing as 1 over cosine of t times 1 over cosine of t. So 1 over cosine of t is secant of t. Reciprocal of cosine is secant. Then this other one is also secant of t. So which makes it become secant squared of t. So here I have secant squared of t. So guys, I have another, oh, I don't like that. I have another Pythagorean identity. This is another Pythagorean identity. This guy. Okay, quickly, let us do one more thing. Your guess is good as mine. Now, if we divided by cosine squared the other time, can we divide by sine squared? Yes, we can do that. So again, I return to from Pythagorean identity. From Pythagorean identity, cosine squared of angle plus sine squared of angle equals to 1. Now, I can divide through by sine squared of angle. Sine squared of angle t. Sine squared of angle t. And if I do that, cosine divided by sine is cotangent, right? Remember, Sine over cosine is tangent. So if you flip that, it becomes cotangent. And because of the squared, I have cotangent squared of angle t plus sine squared t divided by sine squared t, that is 1, equals to 1 over sine is cosecant. And because of the square, I have cosecant squared of t. Again, we have derived another Pythagorean identity. This one. So, do you need to memorize all this? No, not really. Not really. All what you need to remember is our friend here, this guy. Cosine squared of t plus sine squared of t is 1. If you know that, then you know that you can divide all through by cosine squared of t and by sine squared of t. You will get this other Pythagorean identity. How does this help us to solve some problem? Again, let us solve a problem using this approach. If cosine of angle t is 12 over 13 and t is in quadrant 4, find the values of the other 5 trig functions. Look at this. And I want to use this idea. I do know that if this is cosine, cosine and sine are related somehow by the Pythagorean identity. Solution. We know that this guy, cosine squared of angle t plus sine squared of angle t is 1. Meaning that, and I've been given cosine of angle to be 12 over 13, which means I can have 12 over 13 here and square it plus sine squared of angle t equals to 1. Now I can get 144 divided by 169, right, by squaring 12 and 13, plus sine squared t equals to 1. That becomes sine squared t. I can transfer this guy to the other side. Equals to 1 minus 144 minus 169. So sine squared of t equals to, guys, I can write 1 as 169 over 169 because I want it to have the same denominator as 169. So minus 144 divided by 169. Now they have the same denominator. So that means I have 25 divided by 169. So that is sine squared of t. Therefore, I can square root both sides. Sine squared of t equals to 25 over 169. And I can square root both sides. Square root both sides. Then I need to introduce plus or minus here. So this is sine of t equals to plus or minus 5 over 13. I have plus or minus 5 over 13. But recall that our angle is in the 4th quadrant, in quadrant 4. What does that help us to do? In quadrant 4, x is positive and y is negative. So sine is, what am I doing? Yeah, y is negative. So it turns out that, so we can say therefore, sine of that angle is, since it is y value, so minus 5 over 13. So that is sine of that angle. Look at the beauty of this approach. We don't even know that angle, but then we were able to find the sine of that angle because of Pythagorean identity. That said, now we have cosine, we have sine, right? Now we can go ahead and find tangents. We can find cotangent. We can find secant. We can find cosecant. So I hope that makes sense. I will save time by not solving all those things, believing you should be able to do it now. For example, tangent of t is sine of t divided by cosine of t. So which is sine of t, we have it here to be negative 5 over 13 divided by cosine of t is given 12 over 13. So which means we have negative 5 over 13 times 13 over 12. And our answer is, so this takes care of this, negative 5 over 12. Done. Let me do one more. Secant of t is, I do know that secant of t is 1 over cosine of t. So which is 1 divided by, in fact, in this class, we should know, because we are mathematically matured than we were before. That is 1 over cosine of t is, we were given cosine of t to be 12 over 13. 12 over 13. So if we flip that, our answer is 12 over 13 over 12. So that is secant of t. Okay. Now. So I will leave you with the remaining two, I believe, to do cotangent and cosecant. Cosecant is the reciprocal of sine. Cotangent is the reciprocal of tangent. So without doing anything, you should know what the answer is. All right. If secant of an angle t is negative 17 over 8, and our angle behaves this way, our angle is between 0 and pi. Look at it. Our angle is between 0 and pi. Yes, 0 and pi. That is where we have an angle, somewhere there. That is where t is. Secant of t is negative 17 over 8. You should be able to know where our angle is definitely. Because, look at it, okay? I will hold on to that for now. Now, find the values of the other 5 functions, trig functions. We were given secants. How can we get to other angles? Well, secant is related through the Pythagorean identity somewhat. Look at this. Secant squared of angle is 1 plus tangent squared of angle. I can use that. I do know that secant squared of angle t equals to 1 plus tangent squared of angle t. Maybe in your mind, you're thinking, wait, teacher, can I do this? Can I use secant of angle t is 1 over cosine of angle t and just flip it? Cosine of angle t equals to 1 over secant of angle t. Yes, you can do that to find cosine of t. Allowed. So, let me do this. Secant, so that is minus 17 over 8 all squared equals to 1 plus tangent squared of t. If I square negative 17, I will have 289, I believe, divided by 64 equals to 1 plus tangent squared of t. I can subtract 1 from both sides. Subtract 1 from both sides. I need to be careful how I write this. let me write this as 289 divided by 64. Yeah. So I can subtract 1 from both sides. Or I can say I move 1 to the other side. So it's the same thing. Therefore, I have tangent squared of t. I can write this as 289 divided by 64 minus 289 divided by 64. And, oh, no. Sorry, guys. That's not what I need. I need this one. I can rewrite it as 64 over 64. Sorry. So, yes. And now, if I subtract that, this is 2, I believe this is 2, and this is 64 equals to tangent squared of t. So I can square root both sides, square root on both sides, and that means I will introduce plus or minus here. And finally, I can have this place to be plus or minus square root of 225 should be 15. Then square root of 64 should be 8. So equals to tangent of t, which means tangent of t is plus or minus 15 over 8. One more thing for us to do to decide what the sign is. So tangent of t is it going to be plus or minus? Let us figure that out. Okay, the question is, where is our angle T? Let us figure where our angle T is. We can know that, this is tricky, we can know that here, secant, we were given secant, and we say it is negative, right? So, if that is the case, we do know from here that cosine of t is 1 over secant of t. So which means cosine of t is 1 divided by secant of t is negative 17 over 8. So cosine of t is negative 7, 1 is 1 times negative 8 over 17. So which is negative 8 over 17. It means that cosine is actually negative. Now, we understand now that our angle is in the second quadrant because cosine of that angle is negative there. In fact, maybe this is the first thing to do to figure that out. So if that's, we know that it is negative, look at it. Now, we do know that our angle is in the second quadrant where sine is negative. Cosine is what? Sine is y, so it is positive, and cosine is negative. So this is y, this is x. X is negative here, y is positive here. Now, remember that tangent that we are looking for is, tangent is sine over cosine. So meaning positive divided by negative, which is still negative. So it then turns out that the answer is negative 15 over 8. Now, another thing I'm going to teach you is this. Let me put it here. We will always come back to it. In your unit circle, we can have this, and we call it all students takes coffee. All student takes coffee. What that means is that the trig function, all the trig functions here will be positive. Everything is positive here in the first quadrant. Only sign is positive here. Only sign is positive here in this second quadrant. Every other thing is negative. Only sign is positive in second quadrant. Every other thing is negative. Here, only tangent is positive in the third quadrant. Every other thing is negative. And in the last quadrant, in the fourth quadrant, only cosine is positive. Every other thing is negative. Only cosine is positive. Every other thing is negative. Here, only tangent is positive. Every other thing is negative. Here, only sine is positive. Every other thing is negative. So since our angle is in the second quadrant, it means tangent is negative there. Done. Which is what we have here. So do not forget, all students take coffee. Okay, so I have been able to find cosine. I find cosine of angle T. I find tangent of angle T. It remains, so we have secant, we have cosine, we have tangents. Now we need cosecant and we need cotangents. What do we need? Look at this. If I have cosine, well, I know that let me do it here. I know that there is a Pythagorean identity that relates sine and cosine, and that is, it doesn't matter which one comes first anyway. So cosine squared of angle T plus sine squared of angle T is 1. I just find from here that cosine of that angle is negative 8 over 17. So negative 8 over 17 all squared plus sine squared of T equals to 1. So again, I do the same thing. This is 64 divided by 289 plus sine squared of T equals to 1. So I can say this is sine squared of T equals to 1 minus 64 divided by 289. Well, sine squared of T equals to, I can rewrite my 1 as 289 divided by 289 because I want it to have the same denominator as 289. So with that, I can say sine squared of T equals to, I believe that would be 225 divided by 289. And then I can square root both sides and introduce plus or minus here. So that is sine square, sorry, that is sine of T, because I've taken the square root, equals to plus or minus 15 over 17. Again, our angle is in the second quadrant. That is the place where sine is positive here. So in that case, we agree, or we say sine of T is 15 over 17. So we find sine of T. We now know sine of T, cosine of T, tangent of T, secant of T. Um, oh, um, hmm, one sec. Okay, I lost mine. Okay, so finally I need to find, let's see. We have tangent, we have sine, we have cosine, we have secant. So let us find, let us find cosecant of t. Can we find this? Cosecant or cotangent? I already have tangent, so I can find cotangent. I have sine, I can find cosecant, right? So which is reciprocal of sine of t. So which is 1 divided by reciprocal of t is 15 over 17. So our answer here is 17 over 15. Done. And lastly, cotangents of t is the reciprocal of tangents of t. So which is 1 divided by tangent of t is negative 15 over 8. So that will give us negative 8 over 15. Yes, sir. And we are done. So I will leave you to solve this. So you can just pause this video now and try to solve this. In fact, this problem is simple. You have been given sine of t, you were given 2, and cosine of t to be this. Then find this. So find what relates to what and just solve that. Um, I'm going to be ending this video at this point. So next time we are going to be looking at right triangle trigonometry. So be on the lookout for my next video. I hope you understand what we have learned this hour. And if you have any question, don't forget you can ask me um, in class or you can put it in the comment section. All right. So you can share this video if you find it helpful so that other people can learn from it. And till the next time we meet, bye for now.